Hello everyone, my name is Jullaphong Jiamwatthanaloet and today I want to introduce you to a NotebookLM and a concept I call bounded intelligence. We are currently living through an AI explosion where large language models or LLMs seems to know everything about the world, yet often struggle to remember what you told them 5 minutes ago. When we use AI for professional research, academic study, or complex project management, knowing everything is actually a liability. What we need is an AI that is bounded not by capability, but by a specific authoritative context. Today, we are going to look at how Google's NotebookLM achieved this and why it represents a fundamental shift in how we build and interact with intelligent systems. To understand NotebookLM, you have to stop thinking of it as a general chatbot. It is a source-grounded second brain. While a standard chatbot pulls from its vast, frozen training data, NotebookLM acts as a personalized expert, strictly bounded by your trusted information. It operates on 3 core pillars. Strict containment. The system forces the AI to act exclusively as an expert on your uploaded trusted sources. Massive capacity. It is built for scale, ingesting up to 50 sources per notebook, with each source containing up to 500,000 words. Verifiability. It solves the trust problem in AI. Every generated answer includes a citation directly back to the exact passage in your documents. NotebookLM isn't just a reading tool. It's an input-output synthesis ecosystem. Once you provide your sources, the platform transforms that raw data into various functional formats. Reports and briefing. It generates structured synthesis and custom frequently-asked questions to summarize complex topics. Quizzes and flashcards. It serves as an active recall study aid, specifically targeting identifying weaknesses in your understanding. Video and audio overviews. It can create multimodal summaries and even AI-led discussion, which many of you may have seen as the deep dive audio features. Mindmaps. It performs node-based concept identification and extraction, allowing you to visualize the relationship between different ideas within your corpus. Next will be the demonstration of NotebookLM along with some of its features to show you its capabilities in real world. Let's first starting by creating a new notebook. Then it will show you a pop-up to input your sources, and this supports multiple formats like PDF, YouTube, and many more. Or you can also use the research feature to type in the topic and it will automatically find the sources for you. However, for today, I will just use my prepared sources. Let's wait a few seconds for it to process the sources. And now it is ready. Next, I will ask the questions that is related to the topic and the provide sources. Here you can see that the response is generated alongside with the inline citations for every part of the response. So let's look into some of the citations. So here you can click and see where the information come from. So like here we have the PDF files that is downloaded and the sources. There is also a source guide that provides a summary of that particular source. And here you can see that for the PDF files, there is also a figures from the PDF that is also provided to the model. And for this one, you can also see that it is also support YouTube video. And it will use the transcript of the video to provide for the model. Next, I will ask it a question that is not related to the topic and the provide sources, like what is the current price for Bitcoin or BTC? You can see that it will mention that there is no any information related to the current price of Bitcoin from the provided sources, as you can see that it also checked from all the sources that we have. However, it also stated that it can use the discovery tool to search for the most recent financial data from the websites. Next, I will show you the feature that is very useful and I use it very often. It is a mind map. So just click on the mind map button here and wait a few seconds for it to generate the mind map. And now it is ready, so let's look into it together. It is a node-based mind map that contains a summarization of the concepts and key information from the provide sources. And we can look into each of them. And the nodes are also clickable, that when clicked, the AI will summarize that particular topic or information for you. Next, I would like to show you another cool feature of NotebookLM that I really like, which is the audio overview. So just click the audio overview button here, and it will show you a pop-up that you can select the format of the audio overview. You can also choose the language, which also support Thai language as well. And you can set the length of the generated audio. And you can also set the topic. So let me just use this one. Click generate and wait for a few minutes. So let me come back when it is ready. So now that it is ready, I would like to take a minute or two to listen for the content and the quality of the generated audio.
Imagine staring at like $100,000 monthly cloud bill, right? And you suddenly realize that 30% of those incredibly expensive servers you rented are just sitting there, completely idle.
Yeah, that financial drain is honestly one of the most overlooked realities of modern software development.
Right, because your traffic is high, your apps are running fine, but
the underlying infrastructure just doesn't know how to efficiently pack those software workloads together.
Exactly. It's basically like watching someone play a genuinely terrible game of Tetris with your IT budget, just dropping blocks randomly and leaving these massive, expensive gaps everywhere.
That is a very accurate and very painful comparison. When companies scale up, they usually just assume, they need to buy more servers.
When what they actually need is a smarter way to manage the servers they already have.
Precisely.
So, does that change the role of the DevOps engineer? Will the job shift entirely from managing servers to simply building the AI that manages the servers?
That is the big question for the next decade of cloud computing.
It's a wild shift to ponder as you explore these architectural concepts. Thank you for joining us on this deep dive. Keep questioning the defaults, keep digging into the underlying mechanics of the tools you use, and we will see you next time as we continue to untangle the technology that runs our world. Stay curious.
You can hear that the quality of the generated audio is very professional and natural. It really feels like listening to a real conversation rather than AI-generated content. But that would be it for the demonstration. Let's get back to the content. Transitioning from the user experience, let's discuss the technical implementation on how do NotebookLM actually built a system that maintains this level of precision. It requires a shift from standard black box AI interactions toward a transparent, retrieval-heavy architecture. The technical heart of this system is the RAG or Retrieval-Augmented Generation pipeline. This is a 6-stage process designed for maximum fidelity. First, indexing and chunking. Documents are broken down through structural and context-aware segmentation. Second, embedding. Google's native models convert that text into high-dimensional vectors. Third, retrieval. A precision hybrid search captures both the conceptual or semantic and exact word or lexical meanings. Fourth, post-retrieval. BGE re-ranker models filter out the noise, ensuring only the most relevant chunks of data are prioritized. Fifth, generation. LLM constraints are applied via prompt engineering to force the model to adhere strictly to the context. Sixth, grounding. Finally, inline source IDs are attached to the output to provide strict traceability. Source grounding is an architectural requirement, not an afterthought. Precision retrieval. By using hybrid search, the system pinpoints data points based on the relationship between semantic vectors and lexical tokens. Enforced attribution. Prompt engineering compels the model to insert specific source IDs into its generated output. Traceability. The system uses entity relationship diagram or ERD logic to maintain a strict link between the tokens the AI generates and the original retrieved chunk IDs. This architecture is specifically designed to minimize hallucinations. This slide highlights the evolution from traditional RAG to the modern approach used in NotebookLM. In the old way, traditionally, documents were shattered into tiny, isolated vector chunks. This often led to a loss of global context because the AI could only see small pieces of the puzzle at a time. However, in the new way, NotebookLM utilizes a mixture of experts or MOE architecture by utilizing Gemini 3, coupled with a 2 million plus token native ingestion window, augmenting traditional RAG architecture. This creates an advantage by, instead of shattering documents, the system can ingest entire sets of information in a single pass. This preserves the structural and semantic integrity of the data, allowing the AI to understand themes that span across hundreds of pages. We are witnessing a fundamental shift from prompt-centric to source-centric AI. Prompt-centric AI relies on frozen static weights from the model's training. It rewards clever prompting but is highly prone to hallucinations because it tries to guess based on its internal memory. However, source-centric AI, on the other hand, is anchored entirely to the user-provided corpus. It prioritizes closed resource information trust. By minimizing generative freedom, we ensure higher fidelity and factual accuracy. To understand NotebookLM place in the market, let's compare it to its closest rival, Claude projects. Source grounding. NotebookLM is strictly grounded for high fidelity. Claude, on the other hand, blends your sources with its own generalized intelligence, which can be helpful for brainstorming but risky for factual research. Hallucination risk. NotebookLM's risk is minimized via strict anchoring, while Claude's risk is moderate because it may infer or fabricate information outside the sources. Analytical depth. NotebookLM is the surgeon, excellent for high-precision extraction. Claude is the philosopher, better for complex, nuanced synthesis. Citations. NotebookLM provides precise inline clickable citations where Claude's citations precision can be inconsistent. However, we shouldn't view this as competitors but as specialized tools in a researcher's stack. Both have their own advantages and use cases. NotebookLM is the gold standard for high-fidelity research and knowledge acquisition, while Claude is the superior choice for execution, workflow automation, and creative problem-solving. We must be honest about the limitations of strict grounding. In the messy part, if you feed the system unstructured, chaotic documents, you will receive subpar, uncooperative results. While in the clean path, high-fidelity synthesis is only possible when you provided structured, high-quality documents. And for your information, NotebookLM treats your uploads as an absolute authority. It cannot fact-check your documents against the outside world or fill in structural gaps using its general knowledge. This changes our job description. We are moving away from being AI prompters, people who spend all day trying to find the perfect sequence of words to trick an AI into behaving. Instead, we are becoming corpus architects. We are no longer perfecting the prompt, we are architecting a high-quality corpus of context. If the context is perfect, the prompt becomes secondary. When we look at the engineering behind such a tool, we see a series of critical trade-offs. Architecture. Do we go with traditional RAG or long context? Segmentation. Do we prioritize small chunk sizes or semantic coherence? Search. Do we value recall to finding everything or precision to finding exactly the right thing? And lastly, operational logic. Do we choose strict grounding or listening flexibility? For a tool like NotebookLM, the engineering bias is always toward precision and grounding. Now, let's transition from theory to building the actual system. If we were to architect a production-grade version of NotebookLM today, we would need a highly decoupled, scalable stack. At the surface, we have the front end built on React or Next.js to handle the complex state management required for a multi-source interface. This communicates with a fast API or Node.js backend. We choose fast API here because its asynchronous nature is ideal for handling long-running AI inference tasks without blocking the user experience. The real work begins with document processing. We can't just read a PDF. We have to architect it. We use PyMuPDF or unstructured.io for high-fidelity text extraction. For scanned documents or images, we integrate Tesseract or doctr for OCR. The text is then passed through tick token or NLTK for precise tokenization. This ensures that our chunks don't cut off mid-sentence, preserving semantic coherence. Everything is orchestrated using LangChain or Llama Index, which acts as a glue for our retrieval pipeline. Our AI stack is multimodal and multi-stage. Embeddings, we use Google native models or OpenAI's latest offerings to convert our processed text into high-dimensional vectors. Re-ranking, to solve the noise problem in standard retrieval, we implement a BGE or Cohere re-ranker. This ensures that even if a search finds 100 relevant chunks, the top 5 are mathematically the most contextually significant. LLM. The reasoning engine is a frontier model like Gemini 3 or GPT-4. Multimodal generation. For the audio overviews and visual synthesis, we leverage models like VO for video or Nano Banana Pro for complex image generation. Finally, the data store is where the information lives. We use PostgreSQL for relational data, things like user profiles, notebook metadata, and source organization. For the heavy lifting of similarity searches, we utilize Qdrant. Unlike traditional flat file vector stores, Qdrant allows for high-performance vector indexing with advanced filtering. This is what allows strict grounding. We can filter searches by specific source IDs in real time with sub-millisecond latency. The raw files themselves, the gigabytes of PDFs and notes, are stored in S3 or MinIO object storage. This architecture ensures that the system isn't just chatting, but It's performing a precise orchestrated retrieval across a complex multi-layer data environment. In conclusion, NotebookLM represents a move toward AI that is more reliable, more personal, and more professional. And that would be it for this presentation. Thank you for your time and attention.